Hello everyone, welcome to Math 153, Statistical Reasoning. Okay, so we are looking at problem number 10 in the exercises, actually number 23 if you look in the textbook. A corporation must appoint a president, a chief executive officer, a CEO, a chief operating officer, okay, a COO. Do I have to know all this? Yeah, they're story problems. And a chief financial officer, a CFO. It must also appoint a planning committee with 3 different members. There are 17 qualified candidates, and officers can also serve on the committee. Oh, so somebody could be both. So there will be 2 parts here. There will be 3 parts, A through C. And part A is how many different ways can the officers be appointed? And you think, well, does order matter? Well, does it matter who's the president, who's the CEO, and or could you just mix them up and you'd realize, no, you can't mix them up. I mean, imagine any government agency or a club you've been in, and you're in a club and you think, actually, Fred makes a surprisingly good president. And George, he's really doing a good job as secretary treasurer. We are so lucky it's not the other way around, and people like that. They're good leaders, but if they're supposed to keep track of something, no, they aren't going to do it. Or the people who are great with numbers and they don't have the vision and the energy and the whatever it is. There are people that can do both, of course, but usually order matters, and it definitely does in a corporation because somebody has to be in charge and somebody has to not be. So here's the thing that's tricky about this is you also have a committee with 3 different members. And so you can see the 3 here, and then you think, oh, so it's 3 because it's CEO, COO, CFO. That's 3. Yeah, and this is the tricky part. They didn't give you an abbreviation for president, so it doesn't stand out. So watch out for this. Sometimes they give you the same number for both. And that's kind of interesting because then you get to see how different they are. One's order matters and one order doesn't. But sometimes they give you different. So here we have 4 officers where order matters. And then we have 3 committee members. Well, committee combination, that's order doesn't matter. Okay, so now it's just a matter of plugging it in. Once we've noticed that 17 is our N and our R will be 4 for the permutation formula and 3 for the combination formula. We have 17 candidates, and then we have, I told you it's not 3, watch out for it. We have 4 officers. Order matters. So what's our formula? Our formula is NP R. And we noticed that, N equals 17 and R equals 4. The formula for NPR, I'm putting it down here so it doesn't get in the way of that R I just put, is N factorial over N minus R factorial, which is 17 factorial, which is, seriously, you think I would know? I would have no idea. Over 17 minus 4 factorial. It's a huge number. They grow really, really fast. And so you put it in the calculator, which is N and which is R. You're choosing, we're arranging 4 candidates. And if you think about it, well, wait, N minus R, N has to be the big one. Yeah, so N is how many candidates do you have? And R is how many things are you choosing? You have 5 candy bars, you're choosing 2. Well, then 5 and 2. And you have 17 candidates and you're choosing 4. So 17 and 4. Yeah, it's not mnemonic. It's not friendly that, oh, N stands for, wait, what? An R stands, no, it doesn't. You just, it depends on which book you look at. When I learned it, it wasn't R, it was N and K, right? And yeah, dang it. It's like some stuff you just have to, but the thing is, if you put it in wrong, I mean, you'll know really, really fast. 4 minus 17, and then you try to do a factorial, and your calculator will probably throw up all over its shoes or tell you 0, or, and you'll think, oh, well, yeah. If you have 4 candidates and you need to choose 17 officers, how many ways can you do it? And you say, well, what? You can't do it. So I think you'll get it right. What was I up to? I was going off to my calculator, and I'm going to put 17 factorial. If you want me to write it, it's 355,687,428,096,000. And then, I'm not going to write that down. Divided by, here comes 13 factorial. is 6,227,020,800. Yeah, I'm not going to write that down either. Most of you will use a button, right? You'll use a button out of your calculator that will automatically do the NPR for you. But my Windows calculator, doing it by hand, and it wasn't a huge effort, tells me there are 57,120 ways to select officers. So I will pop back to my exercise and I'll key that in, 57120. And of course, don't put in the comma because it'll probably not like it. Well done. We're on to part B. How many different ways can you select the committee? And so here we go. We have 3 committee members. Order does not matter, right? Because there are 3 members on the committee. They sit around a round table and they do their stuff. This is NCR, and our formula is n factorial over n minus r factorial times r factorial. And here, n is 17, but there are 3. R is 3. So I do 17 factorial divided by 17 minus 3 factorial times 3 factorial, which is 17 factorial over 14 factorial times 3 factorial. You have to do these separately, by the way. There's no shortcuts. You can't say, well, 3 times 14 is 42. Let's just do 42 factorial. It doesn't work that way. You know, if you had a 15 on top and a 5 on the bottom, you can't reduce it and say, oh, it's 3. There's a way to reduce it, but it's kind of beyond the scope of what we need to do. I'm going to my calculator now that I have it all listed. And again, if you have the NCR button, and some of you can already see it from my hints, and if you can see it, you might try it, and you'll see how much faster you are than me. 17 factorial divided by 14 factorial is that, and also divided by 3 factorial. And I get 680 different committees. And, you know, people being different, the way they're different, well, some of those committees are going to be really, really good, and some are going to be horrible. Math Lab says, well done. Well, thanks. So, part C, what's the probability of randomly selecting the committee members and getting the 3 youngest of the qualified candidates? Maybe I'll show you that. So this was a great example because it had the permutations and it had the combinations. And notice permutation numbers are typically way bigger than combination numbers. I mean, they can be orders of magnitude bigger. They can be huge compared to. So let's go back to this and just look at it and think about it. I don't know if I need to write this part down because I think you can think of it. So here's the part C of the problem. It says, what's the probability of randomly selecting the committee members and getting the 3 youngest of the qualified candidates? And you think, well, how many different ways, right? So what is this? This is a probability problem, and we know what probability looks like. It's how many ways can you do the thing they're asking about, divided by how many ways can you do anything? Well, how many ways can you get the 3 youngest? Well, if there's 3 of them and they're the youngest, I guess they're the youngest. And you say, well, yeah, but what about, oh, no, they wouldn't be, would they? And so how many ways can you get the 3 youngest? Just one way. It's, see those 3? They're the 3 youngest. Well, what about those 3? Well, they're not, because I just told you the first 3 were the, so there's only one way. So our numerator will be 1. And how many ways can we select committee members? Well, didn't we just do that, Gary? Yeah, we did. It was 680. And so 1 out of 680 ways will be the 3 youngest. And what's the probability? What's the likelihood of that? It's very, very, very small. And so if we randomly, right, the boss comes in and says, hey, I needed a committee to run the talent show. Yeah, right. We're having a talent show and I needed a committee, and so I randomly selected. I just put names in a hat, and then you think, wait, the 3 names he picked, they're the newest hires, right? Because you're going to give the newest hires the grunt work. Hey, Proby, yeah, you're gonna make them do the dirty work, and you'd be suspicious. You think he says he chose them random, but there's only a 1 out of 680 possibility that he would have chosen these 3. I bet it wasn't random, but he's the boss. You can't go to him and say, "Hey, boss," yeah. Don't talk back to the boss. The customer's always right. The boss is also right.